All right, we're going to go ahead and review laws of exponents. So looking at this example, if a and b are positive numbers and x and y are real numbers, then these are our laws of exponents. So if I have a to the x times a to the y, when you multiply, we add our exponents. So for instance, here's a little example. If I have x to the second times x to the fifth, I would have x to the 2 plus 5, which gives me x to the 7th. Okay. So then example 2, if we are dividing and the base is the same, the biggest thing, you guys, is the base has to be the same, which is a, same thing here, we can go ahead and subtract exponents. So we do a to the x minus y. Okay, so if I have x to the 9th over x to the 4th, I would have x to the 9 minus 4, which is the same as x to the 5th. Another thing I want to point out is one rule we would have, let's say we have x to the negative 2nd over x to the negative 5th. Okay. If you guys ever have negative exponents, remember you can take them and move them to the opposite part of the fraction to make them positive. Okay, so this would come down, it would become x to the 2nd, and then I would bring my x to the negative 5th up to the top to become x to the positive 5th. And then I can subtract my exponent, so I'd have x to the 5 minus 2, which this simplifies then to x to the 3rd. Okay, whenever you're simplifying, remember you want to have positive exponents. Okay. The next one is example 3, if we have a power to a power. Okay, so whenever you guys have a power to a power, you can multiply. So if I have a to the 2nd and then to the 3rd, this would become a to the 6th. Okay, for the example 3. One thing I will say is actually about example 4 or rule 4, so I'll do that. So on 4 then, if I have a times b to the x, okay, that means that if they're being multiplied in between, or if they're being divided, I can raise everybody to the x power. So here's a little example. If I have 2x to the 2nd, y to the 5th, all to the 3rd power. Okay, these are all being multiplied, so I can all take and cube each one of them. So this becomes 2 to the 3rd times x to the, it's a power to a power, so 2 times 3 is 6. And then we'd have y to the 5 times 3, so y to the 15th. And I would just go ahead and say 2 to the 3rd is 8. X to the 6th, y to the 15th. Okay. Same thing is true with this rule for division. Okay, so let's say I have 2x over y to the 2nd, all to the 4th power. Okay, I can go ahead and raise everybody, because they're being multiplied or divided, to the power of 4. So 2 to the 4th, x to the 4th, and then it'd be y to the 8th. And then I would just say what 2 to the 4th is. 2 to the 4th is 16. X to the 4th, y to the 8th. Okay. Now here is the biggest mistake that people make. You can only take each one to the power if it's multiplying or dividing in here. If you have this case, if they are separated by adding or subtracting, remember, you cannot just square each part. You must write it twice, and then you have to double distribute or FOIL. Okay. So this does not equal x squared plus 2 squared. If there is addition or subtraction, you cannot do that. So this is like a huge mistake that people typically make in the beginning of calculus. So make sure you aren't doing that. But those are our laws of exponents.